This lesson is Unit 4, Section 3. It is our second day, and we're learning textbook Section 5.6. So we're going to start out with an example where we have f of x equals 3x minus 5, and we're going to solve y equals f of x for x. So basically, we're going to rearrange the equation so that x is by itself. So first, I'm going to change the f of x into y. So we have y equals 3x minus 5. And if I want to get x alone, I would get rid of 5 first. So now I have y plus 5 equals 3x. And my last step to get x alone would be to divide by 3. So I could either turn this into 1/3 y plus 5/3, or there's no reason I can't keep it as y plus 5 over 3. All right, especially because it doesn't go into the second fraction evenly. If this was a 6 and I had 6 over 3, I probably would separate it. I'd have 1/3 y plus 2 if that was a 6. So part B is find the input when the output is negative 11. So we know the output is y. So that means we're going to solve for x when y is negative 11. So we get x equals negative 11 plus 5 is negative 6, and negative 6 over 3 is negative 2. This has a little bit to do with what we're going to talk about today, which are inverses. And inverse functions are functions that undo each other. So they change the input and the output from the original. It flips. So if my original function had an input of negative 2, negative 1, 0, 1, 2, the inverse function would have an output of negative 2, negative 1, 0, 1, 2. And then if the original had a range or an output of negative 1, 1, 3, 5, 7, the inverse would now have a domain or input of negative 1, 1, 3, 5, 7. So it flips the domain and range. The other thing that happens is that the graph of the inverse of a function is a reflection of the graph of the original function through the line y equals x. So for those of you who took geometry last year, if you recall, whenever you reflected in the line y equals x, xy became yx. So you're flipping the domain and range, you're flipping the positions of the x's and the y's. To actually find the inverse of a function algebraically, you're going to switch the x and y and then solve for y. So find the inverse of f of x equals 2x plus 8. So this is really y equals 2x plus 8. Any f of x is really y. And now I'm going to switch the positions of the x and the y. So this is now x equals 2y plus 8. And now our goal is to get y alone. So I'm going to start by getting rid of the 8. So x minus 8 equals 2y. And now I'll divide by 2. So here I will reduce because this goes in evenly. So this is x over 2, or 1/2 x. Negative 8 over 2 is negative 4, and that equals y. And a lot of times what we'll do is we'll write the new one as g of x. So g of x equals 1/2 x minus 4. All right, and that would be the inverse of f of x equals 2x plus 8. Let's do another one. We have f of x equals 6/5 x plus 2. So now I'm going to have y equals 6/5 x plus 2, and we'll switch the x and the y. So x equals 6/5 y plus 2. Start by subtracting 2. And to get rid of 6/5, I would multiply by 5/6. So I will distribute this. So 5/6 x minus 10/6 equals y. So I'm going to write this now as g of x equals 5/6 x doesn't reduce, so it'll stay 5/6 x. And negative 10 over 6 is actually negative 5 over 3. So this would be the inverse of 6/5 x plus 2. So you go ahead and try this one. Pause it, and then you can check your answer. All right, so here the inverse of f of x equals 1/3 x minus 2 is g of x equals 3x plus 6. So far, all we've done are linear functions. So the inverse of a linear function is always another linear function, but nonlinear functions can have inverses as well, but the inverse may not be classified as a function. Since the domain and range of inverses switch, if the range of your original function was not all real numbers, the domain of your inverse will be restricted to whatever those range values were. So if we had an equation where the original range was y is greater than or equal to -8, my domain of my inverse is now x is greater than or equal to -8. So we want to find the inverse of f of x equals x squared minus 2. So this is a quadratic function. My domain would have originally been all real numbers, but my range, this is opening up, lowest point's -2, is y is greater than or equal to -2. So that means for my answer, I'm going to have a domain restricted to x is greater than or equal to -2. So remember to put that in at the end. So I'm still going to do everything the same. I'm going to start with y equals x squared minus 2. I'm going to switch the x and the y. So x equals y squared minus 2. So we'll add 2. So x plus 2 equals y squared. And to get y squared to become y, we would take the square root of both sides, so that the square root of x plus 2 equals y. So my answer is g of x equals the square root of x plus 2 when x is greater than or equal to -2. All right, so we have to include this portion in our inverse statement because this is not a function otherwise unless I count it as x is greater than or equal to -2. Sorry, not a function, but it doesn't work unless I restrict the domain. All right, let's do another one. So right now, my domain of this function would have been x is greater than or equal to 6, because that's the smallest number I could put in here before I get negative numbers. And my range, because there was no number after it, is going to be y is greater than or equal to 0. So this will be part of our inverse function, right? X is greater than or equal to 0. So we'll start with y equals the square root of x minus 6. So x equals the square root of y minus 6. To get rid of the square root, we'll square both sides. So now x squared equals y minus 6, and we'll add 6. So now we have g of x equals x squared minus 6, and that's only when x is greater than or equal to 0. All right, you're going to try the last problem. Pause it, and then you could check your answer. All right, so here we end up with the inverse being g of x equals the cube root of x. There is no restriction on the domain because the original range was all real numbers, so my domain of my new function is also all real numbers. And that is our inverse on, our lesson on inverses.